Let us see about discrete time Fourier transform and its properties. After completion, the students can able to apply DTFT on discrete time signals for solving engineering problems. Fourier transform. The DFT, it is a transformation that maps discrete time signal x of n into a complex valid function of a reality variable, namely f of x of n equal to x of e power j omega equal to summation n equal to minus infinity to infinity x of n into e power minus j omega n, and the discrete and the inverse discrete Fourier transform can be given as x of n equal to f inverse of x of e power j omega, which is equal to 1 by 2 pi integral of minus pi to pi x of e power j omega into e power j omega n into d omega for omega, and a takes the value less than 1. Let us take a equal to 0.5 and we are substituting different values for omega, magnitude as well as phase. Next we can see the properties of DTFT. First one is linearity property. That is linearity property. You want to prove that is the discrete Fourier transform of x1 of t plus x1 of n plus x2 of n equal to x1 of e power j omega plus x2 of e power j omega. And second one is time shifting property. If discrete Fourier transform of x of n equal to x of e power j omega, then we want to prove that discrete Fourier transform of x of n minus n naught equal to e power minus j omega n naught into x of e power j omega. Here, if we are proving this, we are substituting. We want to prove that discrete Fourier transform of x of n minus n naught in e power minus j omega n. Therefore, here let us take n minus n naught equal to m. After making the substitution and we have to rearrange the term, we are proving rearranging the term and splitting this exponential term. We are taking the constant term outside. Finally, we are proving the time shifting property equal to e power minus j omega n into x of. Next one is time reversal. The discrete Fourier transform of x of n equal to x of e power j omega. Then the discrete Fourier transform of x of minus n equal to x of e power minus j omega n. Next one is convolution. If discrete Fourier transform of x of n equal to x of e power j omega and y of n equal to y of e power j omega, then g of e power j omega equal to x of e power j omega into y of g power j omega. Hence, here if you are proving this equation, here we are applying the convolution formula. Therefore, x of n into y of n minus m, x of n convolution x y of n can be given as summation m equal to minus infinity to infinity x of m into y of n minus m. And here finally we are making a substitution that n minus m equal to r, and finally we are rearranging all the terms. Therefore, we are getting that equation as x of j omega into y of j omega. Next one is Fourier frequency shifting. If Fourier transform of x Fourier transform of x of n is x of e power j omega, then the discrete Fourier transform of e power j omega naught into n into x of n can be written as x of e power j omega minus omega naught. And next one is time multiplication. If Fourier transform of x of n is x of e power j omega, then the Fourier transform of n into x of n can be given as minus z into d x of z by dz at z equal to e power j omega. And next one is the Passow's theorem. Here, if discrete Fourier transform of x of e power j omega and discrete Fourier transform of y of n equal to y of e power j omega, then summation of x of n y conjugate of n equal to 1 by 2 pi into integral of x of e power j omega into y conjugate of e power j omega into d omega. We are taking that we are just proving this by using the inverse. Therefore, we are taking the inverse to Fourier transform formula, and also y conjugate of e power j omega. Finally, we are rearranging the term and we are just proving the rearranging the term. We are getting the equation like this, and here we are substituting that x of n equal to y of n. Therefore, we are getting the last equation. Next one is multiplication of sequence. If a Fourier transform of x of n equal to x of e power j omega and y of n equal to y of e power j omega, then x of n into y of n equal to 1 by 2 pi j into y of e power j omega into x of e power j omega. Here we are substituting the value of y of n, that is inverse discrete Fourier transform of y of n, and rearranging the equation, and finally we are getting the values 1 by 2 pi into y of e power j omega conjugate x of e power j omega. Differentiation in the frequency domain. If the Fourier transform of x of n equal to x of e power j omega, then dx of e power j omega by d omega equal to minus j into Fourier transform of n into x of n. These are the sum of the possible quiz questions.